What is the rationale behind safely removing USB media from Windows pieces? Quite often when I'm in a rush, I automatically pull out a USB pen drive or USB cable from an external hard drive from my desktop PC or laptop, without right-clicking on the Safely Remove icon in the system tray and unplugging via this route. So far nothing untoward has happened every time I have been in a rush. What is the rationale behind right-clicking on the Safely Remove icon, and can I really lose information on USB media if this is not carried out? Edit. Is the vulnerability of losing such information greatly increased if the USB media is still flashing at the time of pulling it out of the computer, as opposed to non-flashing?
Yes, it can. It's about what happens if you remove the device when it's in use, reading or writing. When you plug in a USB drive, you give your PC free rein to write and read data from it, some of which is cached. Caching occurs by not writing information immediately to the USB device, and instead keeping it in your PC's memory, RAM. If you were to yank the USB drive out of your PC before this information is written, or while it's being written, you'll end up with a corrupted file. However, Windows automatically disables caching on USB devices, unless you specifically say that you want it enabled. For the most part, you don't have to click the Safely Remove Hardware button if you aren't writing or reading anything from the device. It's there simply as an extra level of security preventing you from destroying your own files. Doing so causes the files to close gracefully, preserving data, pointers and file size indicators. When writing to disk, the computer doesn't always flush a buffer and only part of the data may have been written. Using the proper procedure will assure that the data and pointers are in good shape. Source. A second reason is that flash drives need to have stable power for till 0.25 seconds after a write command. This is a fundamental physical problem. Due random factors, some writes may leave a logical 1 bit in an electrical 0.72 state. The fix is easy. Just rewrite the bit, perhaps even a few times. Eventually it will stick. If you're really unlucky, the bit falling over will be in a file system table and corrupt, for example, an entire directory.
Few people realize everything that goes on under the hood of a flash drive. Unlike hard drives in which a sector is erased and overwritten in a single step, flash drives can write data to a blank 528-byte page much faster than they can perform an erase cycle. Additionally, since each erase control circuit would use up a fair amount of silicon, flash chips generally don't have a separate circuit for each page but instead have one per block, where each block contains hundreds or thousands of pages. This means that every time different data is written to a sector, it will be written to a previously blank area and the old copy marked somehow as out of date. At some point, the flash will perform a garbage collection cycle where it will identify a block that contains mostly out-of-date pages, copy all pages that aren't out of date from that block to another block which has space, and then erase the block. Because such operations may be very slow, some drives will attempt to, when possible, perform them when nothing else was going on. Drives don't tell the computer when they perform such cleanup, because the computer generally won't care. The gotcha is that if the computer doesn't let the drive know that it's about to lose power, the drive will have no way of knowing when it's safe to perform such cleanup. Note that although quality flash drives are designed to ensure that a new copy of data will always be written completely before an old copy is erased, and ensure that they can always figure out which copy of each block should be considered the most current, not all flash drive designs are perfect. In the absence of any power fail notification, An algorithm which is designed to be 100% proof against data loss or inconsistency would probably be at least twice as slow as one meeting looser constraints. Adding a hardware power fail notification which would trip while there was still enough energy to complete one or two flash write operation would reduce the time penalty, but making power fail notifications 100% reliable can be tricky, and not all implementations are perfect.
Failing to safely remove your devices causes phantom devices to remain in Windows. This isn't usually an immediate problem, but once you've amassed a few hundred phantom devices, things start to go wrong. Edit for clarification. Phantom devices are, in short, devices that have drivers installed but are no longer connected to the USB port. Windows keeps track of devices that have been installed, but because the devices hasn't been safely removed, the driver is still loaded for that USB port. This can cause a variety of problems ranging from assigning a new drive letter when you plug in your flash drive to causing video games to detect controllers that aren't there. When you safely remove a device from Windows, you're not just making sure it isn't writing data anymore, you're telling Windows to unload the driver from that USB port. Unplugging your drive on the fly not only risks data corruption, but also risks creating a phantom device that Windows doesn't really handle well. By default, Windows doesn't show phantom devices in Device Manager, which is why most people are unfamiliar with the concept. To find these devices, manually run command prompt as an administrator and enter setDivNgr_show_non-present_devices equals 1. This will allow Device Manager to show the phantom devices for the current session. It is quite possible that there are too many phantom devices to easily remove them all by hand. Ghostbuster is a lightweight GUI designed to easily display and remove phantom devices. Reference this URL.
If you want to support your channel, please consider subscribing.